Okay, so in this Revise With Me video, we're going to be looking at similar shapes. If there's any topic in particular that you want a video added for, just let your maths teacher know and we'll make sure that one's up on the playlist by the end of the week. If you're going to work through these questions with me, don't forget to press pause to have a think about the question before I answer it. And obviously having a piece of paper and a pencil handy will help you with the workings out. Okay, so we're looking at some similar shapes. If shapes are similar to each other, it means that there has been a scale factor involved to change the size of the diagram. So everything in this first diagram would be multiplied by the same amount scale factor to make it this second diagram. Likewise, everything in this second one would be divided by the same to make it into the smaller diagram. So it's handy to have a look at the pair of corresponding sides that you're given to see if you can come up with that scale factor before you even start the question, really. So if I wanted to go from 3 to 9, then I'd know that I'd have to multiply it by 3. So this would be true for any side of the shape from A, B, C, D to make it a E, F, G, H. Likewise, if I was going the other way, I would have to divide by 3. So if I was going that way, it would be a divide by 3. So the question down here asks us to find the length of FG. FG is here across the top. So it's going to match up with the 7. 7 needs to be multiplied by 3. So to find FG, I have to do 7 multiplied by 3. So FG is 21 centimetres long. Question B. So you need to look for a pair of corresponding sides that you can come up with that scale factor before you start. So this 4 centimetres here and this 16 centimetres here are in the same location, so they correspond. And to get from 4 to 16, it must have been multiplied by 4. So for the whole question, all of the sides would be multiplied by 4. And if I wanted to go the other way, and I wanted to go to the smaller triangle, I would be dividing by 4. Part A asks for the length of DF. So I look on the picture for a pair of corresponding sides, and I can see DF here goes with 5 centimetres. So I use that 5 centimetres to help me. AC times by 5 would make the length of DF. So 5 times by 5 tells me that DF is 25 centimetres long. In part B, underneath, they want me to work out BC. So I need to see what sides correspond for BC. BC is here, goes with that 17 centimetres there. So as I'm working from the large triangle back to the smaller triangle, this time I've got to divide by 4. And if I'm going to do that 17 divided by 4, that'll take me back to the BC. So I took EF, divided it by 4, and it'll tell me the BC. 17 divided by 4, 4.25. So I've used colour to highlight which sides are in ratio or are corresponding to each other, but you've always got to make sure you figure that out before you do any calculation. Question 3. Trapezium S and trapezium T are similar. This means that one's a scale drawing of the other. And they want us to find X and then they want us to find Y. So before I do anything, I have a look on the original diagrams and I can see that this side corresponds to that one. So I have a think about what I need to do to get from a 1.5 to a 4.5. or from a 4.5 to a 1.5, and this time I'm happy to say that it's multiplied by 3. And if I wanted to go in the reverse direction, from the big shape to the small shape, I would need to divide by 3. So pairing up my sides to look for x, x is here across the top. Here we have a measurement across the top. So x is with the 2.2. 2.2 is on the smaller diagram. So if I multiply it by 3, I'll have the measurement for the bigger diagram. For part y, this is on the smaller diagram and it matches up to the 9.6 on the larger diagram. So this time the 9.6 has to be divided by 3 to work back to the smaller picture. And 9.6 divided by 3 gives me 3.2. The colours on the diagram really help me make sure that I put the right numbers together. The 2.2 for the x and not being confused using the 9.6 or other way around. Question 4, a pair of triangles that are similar. If the two triangles are similar, then we're looking to find that ratio or that scale factor before we start any questions. I can see the 8 here and the 20 there. I've been given information to say to work out what to multiply by, to go from 8 to 20, or divide by to go from 20 to 8. Well, this isn't a whole number this time because 20 is not in the 8 times table. So I just need to have a think. I just need to try some numbers. I think it's going to be 2.5. So I'll try 8 multiplied by 2.5. Yeah, that's going to work. That's going to give me 20. So every time this has to be multiplied by 2.5 to get to the bigger triangle. And likewise, if I want to get to the smaller triangle, I'm going to be dividing by 2.5 or 2.5. So if I want to work out angle x, side x, I need to use the 6. That's the corresponding side on the small triangle. And the 6 has to be multiplied by 2.5. 2 6s are 12, half a 6 is a 3. That's going to be 15. And then if I want to work out y on the small triangle corresponds to the 25 on the big triangle. Because I'm given the 25 on the big triangle, to move to the smaller triangle, I'm going to need to divide by 2.5 or by 2.5. How many 2.5s are there in 25? Or how many 2.5s are there in 25? And that would be 10. Okay, so matching sides, 5 to 8. They correspond, they're where I work out my ratio. 5 to 8 is not going to give me a very nice number. It gives me an answer of 1.6. I worked it out by doing 8 divided by 5 on my calculator. This told me what I need to multiply by, and if I was going the other way, it'd be exactly the same number for dividing by. They only want FG. FG is across the top of this large side, the long side here, corresponds to the 9. And because I'm trying to make it to the big triangle, I've got to multiply by 1.6. So I take my 9, I make it 1.6 times bigger. And I get 14.4. This time I got 3 similar rectangles, but because they're similar, the scale factors work for length and width, and for length and width. Okay, so these corresponding sides here are all linked. If you look at the first question, question A, we need to look at this relationship so that we can then work out the length of x. So we will need to say 15 divided by 12 is 1.25. So to get from this one to that one, we multiply by 1.25. And if we've got 30, we need to multiply by 1.25 so that we can get x, 37.5. And then if we're going to have a look at part B, we need to look at this relationship here so that then we can use it to find that y value there. So if you look this time, it's getting smaller. It's actually been divided by 3. So we'll take our 30, we'll divide it by 3. So that must be 10 centimetres there. Question 7, the two triangles have been plonked one on top of the other. So it's a good idea to separate them back out so that it's easy to see, so that you're not trying to read one picture, but you got them separate so that you can see both. So if I just draw them at the bottom here separated, I can see the small triangle has 8 and 6 for the A to B and B to C. But on the big triangle, A to D is the entire length of the 8 and the 4 put together. So if I don't see it on a separate diagram, it can be a bit confusing because that 4 isn't the length, it's just the added length to make A to D, which is 12. So looking at my two triangles at the bottom of the page, these are the sides that I'm given that are corresponding. So you have to work out what you need to do to an 8 to make it into a 12. What do we need to multiply it by? So that's actually going to be multiplied by 1.5. It's 1.5 times bigger. And if we want to find the length of DE, DE is across the bottom here and corresponds to BC on that smaller triangle. So you take your 6, you make your 1.5 times bigger, that would be 9, and that would be your DE. But separating the two triangles into two pictures makes it a lot easier to see what's going on.